All right, we'll give it a shot. Hey, that was inappropriate. Don't say that. So, glucose. Glucose is the simple sugar. It's like the simplest form of a sugar. Now, what's dehydration synthesis mean? What's synthesis mean? Say it again? Putting together. Good. So, two glucose molecules. Oops. Two glucose molecules added together, that's synthesis, and then what's dehydration mean? No, you don't have to write this. Pay attention. You can write it if you want. What's dehydration mean?
Like
losing water. Right. So you add these two and then subtract an H2O. What's the formula going to be?
It's going to be C6H10O5. Right?
Let me do the first part first. Add those two together.
Oh yeah. So C12.
C12, H24,
and O12.
and O12. Now subtract an H2O.
So C12, H22, and then O12.
Very good. That's sucrose. That's sugar. Write this down. That's sucrose, also known as sugar. Okay? So why am I talking about this? Because I want you to understand the properties of elements are very different than the properties of the compound they make. Carbon is black. It's over here. Pure carbon's black. Okay, this is pure carbon. It's black. If you want to eat that, you can, but it's going to taste terrible. So, bad taste. Solid. These are problems.
Can Ryan eat that or something?
No, you cannot. What about hydrogen? What physical state is hydrogen?
Gas.
Gas. Colorless. Doesn't really have a taste. What else can you do to hydrogen?
You can liquefy it. I bring it for like
Yep.
Yeah.
Yeah, you can do that to almost anything though. This is unique about hydrogen. It's why when I put sodium in the water, it caught on fire. Yeah, it's producing hydrogen gas, and that hydrogen gas caught on fire because when you put sodium in water, it gives off heat. It's exothermic, gives off heat. That heat heats up the gas, and it burns. So it's flammable. Oxygen is basically the same. Same properties. It's gas. It's a gas. It's colorless. It's flammable. We did that in lab today, yesterday. Okay, when you put the glowing splint, caught on fire. So, what about sugar? Properties of sugar. You all know.
Solid.
Sweet. Solid.
White.
White. Good enough. None of the same properties. Okay, yeah, carbon solid, sugar solid, but that doesn't really, that's a coincidence, I guess. So, the point is these three elements make up sugar. Sugar is very different than the three elements, and that's because it went through a chemical change. The composition changes. Okay? Composition changes. These numbers here really dictate the properties. Okay? Really dictate. Think about it. Water is H2O. Hydrogen peroxide, H2O2. Very different. So you start changing these numbers a little bit, changes in, you could, and in fact, if you make the right proportion, it could be lethal. You could eat it and die. You can't really die from sugar. I mean, you can. It's going to take a long time, but and it will shorten your life if you eat a lot of it, but that's a different story. Questions? Okay. So we're done with elements, compounds, and mixtures for now. We're going to take a break for a second and learn about significant figures. Has anyone ever heard of significant figures? All right. It's the first time for everything. Significant figures. Oops, I forgot my second eyelid. Significant figures. All right. Significant figures. What is a significant figure? Let me use this to explain. Okay? I gotta come around. So I can't get it on recording here. Who's it gonna be? Oh. Which one has more lines on it? This one. Why does this have more lines on it? Ah, measure more precise. Give me another word. Start with an A. Accurately. Okay. How many lines between 20 and 40? No, between 20 and 40. One. So there's 20 on the bottom, and then there's a line, and then there's 40. What about between 20 and 40 here? A lot? Probably about 20 lines, almost. So between 20 and 40 here, there's one line. Between 20 and 40 on a graduated cylinder, there's about 20 lines. Why am I showing you that?
Significant.
Which one is a more significant measurement? This is more significant. Okay? Here's why. You don't have to write this, you can just watch. The beaker has a big line, 40, little line, big line, 20. What's that?
30.
30. So if I say, take this beaker and measure 25 milliliters of water, or 22 milliliters of water, you're basically going to be doing what?
Eyeballing it.
Yeah, guessing. Okay? So, you know, your meniscus is going to be somewhere in here, and I don't know if that's 22. Okay? If this is 30, you know, maybe, but you're guessing. But if you use a graduated cylinder, okay, and you count the number of lines, let's say just between 20 and 30, there's going to be 9 lines. So it's going to be 20, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 30. Each line represents what?
1.
What's that? I can't hear him.
A number.
A number. What number? What is that volume right there? 21. So that's 1, right. So 21, 22, 23, 24, 5, 6, 7, 8, 9, and then 30. So 22 would be right on this line here, okay? That would be 22. That's very accurate. That's more significant. So this mark is 22. That mark is 20-something. So what I'm trying to use is a very simple example. These numbers go up by 10, okay? So 20, 30, 40. These go up by 1. 20, 21, 22, 23. 23. These numbers are actually 2 decimal places, or 2 places, place values, we'll say. This is really just 1. Zeros make it confusing. In other words, I can't ever have a number between 30 and 40 on this beaker. Not really. But here I can, because it goes up by 1. So because there are individual, the ones place is being filled, it's more significant. So you can make a more accurate, more significant measurement with this than you can with this. Plus, I told you never to use a beaker. Why?
Because it's not the lines.
The lines are all screwed up. These are not even close to the right volume. Sometimes they can print it on them like crooked. It's like a joke. It's really just to kind of estimate. So that's very significant. That's very significant compared to this. There's a lot of guessing going on. Let me give you another example. I want you to write this one down. You got 2 scales. Okay? Scale number 1. Scale number 1. And you got scale number 2. And you put the same, I don't know, you got a piece of copper 2 chloride. Okay? You put it on the scale. The mass on scale number 1 is 8.42 grams. The mass on scale number 2 is 8.4 grams. Both scales. I have scales in here that go out to the hundredths and only go out to the tenths. Which number is more accurate? Which number is more significant? Right.
Scale number 1.
Right. This is a more significant number. It has 3 decimal places. 1, 2, 3. This number would have 3, what we say, 3 sig figs. That's how we say it, 3 sig figs. This number would only have 2 sig figs. Okay, we abbreviate, it's easier to say. Sig figs. Does that make some sense? Hopefully, to some of you. See, in chemistry, some of these scales go out even further. What's up, Mr. Gallen?
Kristen's signature on something?
Yeah, sure.
I'm taking this.
So, at Geneseo, far superior school to Siena, there was a room where you massed chemicals between the labs. It was a room just for massing. So you walked in this room and they had these scales. You guys know what the Pope rides around in?
Popemobile.
Yeah, I know, but like the glass, whatever, bubble, I find that really funny. Anyways, that container that he's in, imagine that over a scale. And the reason they do that is because some of the numbers, I remember getting a measurement something like that. Can anyone even say how many decimals? I love chemistry. Yo, that is nice. Some kid's gonna watch that. You're like, they're gonna see me. Yeah, they're gonna be scared. You know, you guys probably don't even know what decimal place that is. But anyways, the scales are super sensitive. That's really significant, okay? Because it goes out so many decimal places. I'm not making that up. They had a room just for scales. And you couldn't like slam the door or open the door quickly because any air current would screw up your measurement because you had these tiny amount of chemicals. It was ridiculous. It was like a piece of dust on the scale. That's what we're talking about.
On the scale.
What's that?
Where dust got.
Well, the room was sterile. You had to wash your hands before you went in. Make sure your feet, you weren't too dirty. So, I mean, it's not like you're wearing suits, like that kind of sterile. But
Like Ebola.
right, not like that.
It's just a room with a single scale.
No, there's like 6 or 7 scales, maybe 8.
It's just like a little like stand in the middle.
The scales are crazy. The scales are like $800 each at least. Anyways, the point I'm telling you the story, the reason I'm telling you the story is significant figures. The more decimal places will be more significant. Let me teach you how to figure this out though. So the goal today, we only got 5 minutes, but the goal is to be able, if I write a number on the board, you tell me how many significant figures it has. So let's start with the US of A, America. Imagine you're looking at a map of our country. You look over on the west coast. What ocean is over there? Pacific. Your notes, right? Pacific. Over on the left side. What ocean is on the right or the east coast? Atlantic. So right Atlantic. Underline the A, underline the P. The P stands for present, and the A stands for absent. Present and absent. What does that mean? Decimal point. That's what it means. If a decimal point is present or if a decimal point is absent. It makes no sense yet. Give me a couple minutes and it'll make sense. I'm going to write 5 or 6 numbers down in the middle, okay? Kind of in a line here. And then we're going to go through and I'm going to use the Pacific and Atlantic to teach it. Here we go. First number, 2300. Next number, 60. Next number, 0.034. 606. 0.1300. And we'll go with 9.05. And we got to put units on this. 2300, we'll say meters. 60 centimeters. 0.034 milliliters. 606. I don't know, kPa, which is a kilopascal, which is a unit for pressure. 0.1300 moles. Ryan likes the mole box. Moles, so you need to measure. Mole day, coming up 24 days from now, October 23rd. You dress up like a mole, you get bonus points.
How many bonus points?
A lot. And you can, if you want to make cookies or cupcakes or something in the shape of moles, you get extra credit for that too.
Has anyone ever done
In
that?
the shape of like an animal mole?
There's someone drew a picture of a mole. I have a really good picture of it. What did I do with it? Oh, I think I took it off the wall and put it in my drawer.
Show us the picture.
It was Isadora, exchange student from Brazil.
I want to see it.
You guys remember her?
I want to see
Yeah.
it.
Yo, that was
Like her, Zach?
that was very enthusiastic. Is a door.
I know. He's got all fired up there. Maybe one day you can get your passport and go down. Here we go. So, anyways, she made the picture of the mole. It's
Did she
awesome.
get a lot
I'll
of
show you.
extra
It's in
credit?
there. I'll show you some other time.
Does she get a lot of extra credit?
I helped her.
If I draw a really good picture of the mole,
Stay with me. I gotta give you the homework. All right. Now, this number has no decimal point. So decimal point absent. We start on the right side. Draw that arrow. Now, to count significant figures, you skip any zeros. So you do not start counting with them. They do not count. So no, no, yes, yes. 2 significant figures. 2 sigs. 2 sig figs. 60 centimeters. Start on the right. You can't start with a 0. 1, just 1 significant figure. Decimal point present. Start on the left. That's why we do Pacific Atlantic. Treat the number like it's the country. Left is the Pacific side. Decimal point present. Don't start with the zeros. They don't count. 1, 2. 2 significant figures. 606. Start on the right. Decimal point absent. You can start with a 6. 1, 2, 3. Well, wait a second. Why do you count that 0? You count zeros once you start counting. You just can't start with them. Okay? Decimal point present. Go to the Pacific side. That's a 1, so we can start 1, 2, 3, 4 significant figures. Same thing down here. Start from the left. You can start with the 9. 1, 2, 3, 3 significant figures. I went quick because I'm running out of time. But your homework, we'll practice this. If you make all types of mistakes, that's okay. We'll go through it. After tomorrow, you will get it. I promise. Okay, hold on. Worksheet. Sorry, we got...